Hello everybody, my name is Rishi. Today we'll be doing Deep ML problem number 34. The problem is one hot encoding of nominal values. Our task is to write a Python function that performs one hot encoding of nominal values. The function should take in a 1D input of a numpy array of x integers values. In this case, it's a torch.tensor because we're doing this in PyTorch. And an optional integer encol representing the number of columns for the one hot encoded array. If encol is not provided, it should be automatically determined from the input array. Okay, so it provides us a hint to use torch.nn.functional.oneHot. However, I'm going to do that, but that's also very, very boring because it's just a function call and there's no analysis of what happens behind it. So I'll code up the solution for using that, and then we can get back to actually solving the problem using basic PyTorch and logic. So torch.nn.functional.oneHot takes in two values, takes in x, a tensor, takes in encalls, or num classes. So with that, because encall is optional, it's just if encall is not none, then we do this with encall in it, and return that. Also notice that the output, it seems that the output is a float because it has a period after it, even though the input is an integer. So I'll do .to torch.float32, and else we return torch.nn.functional.oneHot of x.to torch.float32. And I don't need an else there because return functionally operates in that else sense. Okay, so this should work. What this does is it calls the function. If it has number of columns, then we'll use that. You see it passes the test case. If it doesn't, then the function infers number of columns for itself. And then .to torch.float is just so our output matches their output. So if you just wanted the basic simple solution, that is it. But now it gets more complicated. We can do this by hand, of course. We don't need a function call for it. And the way to do that is first find num classes if not given. Second is implement one hot encoding. And then third is return the tensor dtype equals torch.float32. Okay, so let's go through that in steps. Also, for those who don't know, one hot encoding is where we essentially create a new array of arrays, and each array inside this array is a row of values from values of 0, 1. The position of the 1 encodes what value that is representing. So if 1 is at the beginning of the array, then it represents 0. If 1 is the second value, it represents 1. 1 is third value, represents 2, so on. If we had a 3 in here, then 1 would be in the 3's position. It'd be 3 zeros down, and that would represent 3 then. So num classes, since we can infer it from the max value, because num classes is essentially equal to the number of columns. So num classes is the number of columns, but with a caveat that it's the number of columns is the same thing as the maximum value here plus 1, because we need to encode all numbers from 0 to n, and the way to do that is we need n plus 1 columns because we need to count for 0 as well. So num classes equals ncall if ncall is not none, else it is torch.max of x.item plus 1. And torch.max just gets the max value in this x tensor, pretend that's a tensor, and so in this case it'd be 2, makes that into a dot item because torch.max returns a tensor, so it turns it into just a plain integer value and adds 1 to it, so we get 3 then, even if it's not passed in. So now for one-hot encoding. So let's define the list that we're adding to, so encoded list as that. And in one-hot encoding, a baseline is 0. So we always start encoding from 0. So usually. So like if we had a list of like 1, 2, 3, 4, 5, that would have 6 columns because we have to account for 0 even though 0 is not inside the list to encode. So now let's move over each value in the tensor. So for val in x.toList, this just loops over every value in the passed in tensor, assuming that we can convert it to a list. And I'm guessing we can because it's a 1D integer tensor. And let's create a val encoded list. Val encoded will be a list that contains the numbers that correspond to the encoded nominal value, or val for short. So the first thing to do is always we need to account for val being 0 or not, and like for not being a 0 number. And the way we can do that is whenever we have a number such as, for example, 2, that number will be that number of zeros in. So 2 is encoded by putting a 1 after 2 zeros in a list. 1 is encoded by putting a 1 after 1 0 in a list. 0 is encoded by putting a 1 after 0 zeros in a list. So always, if val is not equal to 0, then we just add val number of zeros to the list, or to val encoded. So val encoded plus equal 0 times val. So this adds a val number of zeros to the list. And the reason I don't do that with 0 though, I'm doing it if val is not equal to 0, is because if val is 0, then we get an empty list that's being added in. And an empty list would mess all sorts of things up anyway. Okay, now once we're in there, once we have like two zeros added for the case of 2, let's say now we need to add the 1 for sure, because whenever you have a value to encode it, we just add that value's number of zeros and then add a 1. So val encoded plus equals list of 1. Now the last thing is to append however many zeros we need to get to the num class's number. Because we want val encoded, we want the length of val encoded to be num classes. So if length of val encoded is not num classes, then we want to append zeros until the length of val encoded is num classes. And the way we do that is by finding the number of zeros that we need to add. And the number of zeros we need to add is simply the difference between val encoded and num classes. However, it will always be the other way around. It will be num classes minus val encoded. Because remember, num classes is bigger than val encoded, or length of val encoded. So, and we can't multiply by a negative number, so it must be this num classes minus length of val encoded. And then at the end, we just append, so append to an encoded list. And now we're on to the last step, return the tensor. So return torch.tensor of encoded list dtype equals torch.float 32. Looks correct. Yep, and it passes the test cases as well. So now you've seen how you can implement your own torch.nn.functional.onehot. Admittedly, this is not very optimized because Python lists themselves are very slow. It would be better to use something like NumPy for this. But either way, we solved the problem. So yeah, thank you. Code is in the description below.